You know how it is when you're working with a database. Some tasks are just tedious. Creating IDs, calculating values, combining names. What if the database could just do all that work for you? Well, guess what? With PostgreSQL, it absolutely can. Today, we're diving into 3 really powerful ways you can automate your columns, which is going to save you a ton of time and prevent a whole lot of headaches.
All right, so here's what we're going to cover. First, we'll talk about why you'd even want to automate this stuff. Then, we'll look at the classic way to do it with Serial. After that, we'll level up to the modern SQL standard identity columns and then check out the super clever generated columns. And to wrap it all up, we'll put them all side by side so you know exactly which tool to grab for the job.
So really, why bother with any of this? Well, the idea is simple, but it's really powerful. Let the database do what it's good at. This isn't about being lazy, it's about being smart and efficient. When you let the database automate columns, you write less code in your application, you guarantee your data is more consistent, and honestly, you just make your own life a whole lot easier.
Ugh, right? We've all been there. Every time you have to write an insert statement where you first have to go find the last ID, add 1 to it, and then plug it in, it's just asking for trouble. Or what about having to constantly stitch together a full name from a first name and last name in your code? There is a much, much better way. Okay, so let's start with an old friend. This is the tool most of us meet first on our PostgreSQL journey, the serial type. It's the original go-to for creating a simple, auto-incrementing number, which is perfect for things like primary keys. It's been around forever, and it's super straightforward to use.
Now, the most important word here is shorthand. See, serial isn't really a data type in itself. It's more like a bit of PostgreSQL magic, a shortcut. When you declare a column as serial, what Postgres actually does is create a standard integer column for you, and then it links it up to a sequence, which is basically like a ticket dispenser that just hands out the next number in line every time a new row gets added.
And this is why people love it. I mean, look how easy that is. With just one simple alter table command, we've basically told our table, hey, from now on, you're in charge of the university ID. All that manual work? Gone.
And here's the payoff. Take a look at this insert statement. Notice what's missing. We're not telling it what the university_ID should be. We just give it the data that actually matters, the name and the address, and we trust that PostgreSQL is going to handle the rest. And voila, here's the result. Boom, the university ID is automatically set to 1. The very next time we insert a row, it'll be 2, then 3, and so on. The database handled the ID generation all on its own. It's clean, it's simple, and it just works. But as handy as Serial is, there's a little hint, even in the official documentation, that points us toward a better way. It calls Serial a convenience, but it also nudges us to consider a more modern SQL standard approach. So think of this as our cue to level up our skills. And that brings us to the identity column. This is the real deal. This is the official SQL standard successor to Serial. So if you want your database skills to work on other databases like Oracle or SQL Server, this is the syntax you want to learn. Plus, it gives us some really important new powers. Now, under the hood, an identity column is still using a sequence to generate numbers just like Serial. But the key phrase here is more control. This isn't just a simple on or off auto incrementer. It's a configurable one, and that difference is a total game changer. And this is the control I'm talking about. You get to decide how strict the database should be. Generated always is like a strict bouncer at a club. It will flat out reject any attempt to manually insert your own ID. And this is perfect for primary keys, where you never ever want an override. Then you have generated by default. This is more of a helpful host. It'll generate an ID if you don't provide one, but it will gladly let you specify one if you need to. And that's incredibly useful for things like migrating old data.
Okay, quick but super important PSA. An identity column will happily generate numbers for you, but it does not automatically guarantee that those numbers are unique. If you use generated by default and manually insert an ID that already exists, you can create duplicates. So please, 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 always pair your identity column with a primary key or a unique constraint to let the database truly enforce the rules. All right, let's totally switch gears. So far, everything's been about generating IDs, creating new sequential values. Generated columns are completely different. They're not about creating new information from scratch. They're about computing values based on other columns that are already in that same row.
And honestly, the best way to wrap your head around this is to think of a spreadsheet. You know how you have a number in cell A2, another in B2, And then in C2, you type a formula like equals A2 plus B2, and it just magically calculates the answer? A generated column is exactly that, but for your database table. It's a living formula.
And the syntax is actually pretty easy to read. We're creating a new column called university_full_info, and we're telling the database its value is generated always as this expression. In this case, we're just saying take the name, add a comma and a space, and then tack on the address. And that stored keyword just tells the database to physically save the result to disk, so it's always ready.
So here's what that looks like in action. All we did was insert Harvard and Cambridge. That's it. The database saw that, ran our little formula, and automatically filled in that third column for us. Just think about that. You will never have to write application code to join those two strings together ever again.
But wait, it gets even cooler. This isn't just a one-time thing when you insert a row. If you go back later and update the address for this university, Postgres is smart enough to automatically rerun the formula and update the university full info column to match. This means your computed data is never stale or out of sync. It is literally self-maintaining data.
Okay, we've looked at the classic, the standard, and the formula. Now let's put them all side by side to make it crystal clear which one you should be reaching for and when.
This table pretty much sums it all up. First up, purpose. Serial and identity columns are your ID generators. Generated columns are your calculators. Can a user override them? With serial, yes. With identity, it depends on your setup. With generated, absolutely not. The formula is the formula. Does it reference other columns? Serial and identity don't, but that's the entire point of generated columns. And finally, the SQL standard. Identity and generated are the modern, official way to go, while serial is a Postgres-specific classic.
So what's the bottom line? Here's your cheat sheet. For simple, older, or PostgreSQL-only projects, serial is totally fine. But for any new development, you should really be using identity for your IDs. It's the standard, it's more flexible, and it's just the better choice. And anytime you find yourself needing a column that is just a calculation or combination of other columns in that same row, a generated column is the perfect tool for the job.
And there you have it, 3 incredible tools to make your database smarter and your job a whole lot easier. By letting Postgres handle these automated tasks, you end up writing less code, making fewer mistakes, and building much more robust and reliable systems. So the only question left is, which one are you going to build into your project next?